Today in science class 8th grade, we're going to take a look at these IXL activities, H.3 and H.4, in which we're exploring different types of energy transformations. In lesson 2 in chapter 13, we learned about how energy does not get used up, not produced, but it's changing form. It's transforming from one form to another. And we're going to take a look at two real-life examples. The first one, H.3, is in a roller coaster scenario. If you've ever ridden a roller coaster, you've probably not thought about the different types of energy transformations that are taking place. You've just simply experienced the fun and thrill of that ride. Let's look at the science that goes into the energy that powers a roller coaster. There are many types of energy. One type is kinetic energy, which is the energy of an object moving. Read the passage about the start of the roller coaster ride and think about the kinetic energy of that roller coaster train. At an amusement park, a group of riders boarded a roller coaster train and sat down. Once everyone was safely in their seats, the rider operated a switch, the electricity flowed to a motor below the track, and the motor pulled the train forward out of the station. Which of the following is better evidence that the train's kinetic energy changed? Well, electricity started flowing to the motor when the operator flipped the switch, or the train was stopped and then began to move. If we're talking about kinetic energy, we want to focus on the fact that it was stopped and now it's moving. So we've got this idea. When the amount of energy changes, energy transformation is happening. When one or more types of energy decreases, at least one other type of energy increases, kind of like a seesaw or teeter-totter. This is because during energy transformations, energy is converted between different types. Read the passage again, think about the energy transformation. At an amusement park, a group of riders boarded a roller coaster train and sat down. Once everyone was safely in their seats, the rider operator flipped a switch, electricity flowed from the motor below the track, the motor pulled the train forward out of the station. Complete the sentence. Here's our conversion, energy transformation. The motor was used to convert what type of energy into what type of energy? Looks like a switch was flipped, which would say electrical energy is being used to get that train moving, which would be kinetic energy. During an energy transformation, the total amount of energy stays the same. So when one type of energy decreases, the other increases. Read the passage again and think about how kinetic energy and potential energy go back and forth. Roller coaster train slowly moved away from the station and over the top of a tall hill. It might come to this section and then the low click, 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 click. It's getting pulled up this huge, massive hill that then generated the energy to fall down that hill. As the train began to rush down the hill, the riders felt like they were rising out of their seats. The train sped up until the track flattened out at the bottom of the hill. At the bottom, the riders felt like they were being pushed down into their seats. Click the blue words to correct the statement. As the train rushed down the hill, the kinetic energy of the train stayed the same. Well, they're moving faster, so we would say that the kinetic energy increased. The gravitational potential energy stored between the train and the earth decreased. Because as you get all the way up here, energy position, the higher you are up, the more potential energy you have. But as soon as you start to fall, that potential energy goes away. The potential energy turns into kinetic energy, which we said increased. So if one's increasing, the other has to decrease. Now, it says read the same passage and think about the evidence that kinetic energy and gravitational energy changed. Here, consider the following claim. As the train rushed down the hill, gravitational potential energy was converted into kinetic energy. Which piece of evidence best supports this claim? Well, the speed of the train increased as the height of the train decreased, or the people in the train felt like they were being pushed down at the bottom of the hill. We would say that the speed is probably the greatest indicator here as your evidence to how this is changing, because the potential energy is being changed into kinetic energy, and speed is an indicator of how fast you're moving. So if you're moving faster, that energy transfer has occurred. Read the passage about the next part of the ride. Think about the energy transformations between kinetic and gravitational potential energy. Remember, kinetic energy is the energy of motion. Potential energy is the energy of position, so wherever it's located. Next, the roller coaster train went through several turns and sped toward a shorter hill. As the train rolled up the hill, it slowed down. Then the train went over the top of the hill and sped up again as it raced down the other side. Complete the statements. As the train went up the hill, blank was converted into blank. Well, it was moving fast and then it slowed down, so if it's slowing down, we're going to say that the kinetic energy was transferred into gravitational potential energy. As the train went down the hill, what was converted into what? We'd say gravitational potential energy was changed back into kinetic energy because it sped up again. Energy transformations often involve more than two types of energy. Read the passage about the end of the ride. Think about the evidence of change in kinetic energy, sound energy, and thermal energy. The roller coaster train went through a final big turn and then headed back towards the station. The train slowed down as brakes on the track squealed and heated up. Once the train came to a stop at the station, the riders stood up and left. Match each claim with the evidence that supports it. The brakes heated up. The brakes squealed, the train slowed down, the riders stood up, the train changed direction. Here's the claim and here's the evidence. Kinetic energy decreased. Well, we would say that the train slowed down because we're talking about the movement of that train. Thermal energy increased. That would be the brakes heating up because there's friction between the brake pad and probably the rail of the train. Those things are going to heat up. Sound energy increased. Well, that would be the brakes squealing because of that friction that's taking place. Claim and evidence. So here's how we know that that energy transformation is taking place. See if we got it right. Nice work. What is sound energy? Sound energy are the waves that travel through air, the other types of matter. Each of these waves carries energy, which is called sound energy. It's the vibration, it's the movement of those air molecules. In all energy transformations, the type of energy that decreases are converted into the types of energy that increase. Read the passage, think about the energy transformation between kinetic and sound and thermal energy. So we just read this, so it went through the final big turn, comes to a stop, slows down, complete the sentence. While the train was braking, blank was converted into blank. Kinetic energy was converted into sound energy and thermal energy. Do all brakes produce heat and sound? All roller coaster brakes produce heat, and some brakes on modern roller coasters are nearly silent. These brakes use magnets that are part of the track. When metal on the train passes the magnets slow down the train. As the train slows down, the brakes produce thermal energy, but sometimes no sound energy because the way in which modern technology, they don't want that to hurt the rider's ears and make it a bad experience for them. Click the blue text to correct the passage about energy transformations during the roller coaster ride. At the beginning of the ride, the motor converted electrical energy into kinetic energy. Kinetic energy into electrical energy? No, electrical energy into kinetic energy. That's good. This caused the train to move out of the station and over the first hill. As the train went down the first hill, kinetic energy was converted into gravitational energy. We want to put that in the other order because it went up that hill, creates potential energy, was converted into kinetic energy as it went down. Next, as the train went up the second hill, kinetic energy was turned into gravitational potential energy because it slowed down. Then the train went down the second hill and moved back towards the station. Finally, when the brakes squealed and heated up at the end of the ride, sound energy was converted into kinetic energy. We want to say that kinetic energy was turned into thermal energy and sound energy. That's a good synopsis or a summary of what we just went through the entire scenario of our roller coaster ride. Nice work. Based on what you learned about the roller coaster ride, which of the following statements about energy transformations are true? Select all and apply. Kinetic energy can be converted into several other types of energy. Yep. A change in object speed is evidence that object's kinetic energy is changing. Yep. Only gravitational potential energy can be converted into kinetic energy. Gravitational potential energy can be converted into kinetic energy. So the energy position turns into movement. I would agree with that. Never mind, not the last one. Based on what you learned, roller coaster ride, this answer is not correct. Kinetic energy can be converted into several types of energy. Only gravitational potential energy can be converted into kinetic energy. That's not correct. At the start of the roller coaster ride, electrical energy was converted into kinetic energy, not gravitational potential energy. So they're saying that electricity was used to get the roller coaster moving at the beginning. Other types of energy can be converted into kinetic energy, not just gravitational potential energy, even though potential energy goes into kinetic energy and it's a back and forth between those two. So it's kind of a trick question. Got it. That should complete H.3. We're going to go over to H.4, which is the energy transformations of a bike ride. There are many types of energy. One type is kinetic energy, which is the energy of an object when it is moving. Read the passage about a bike ride. Think about the kinetic energy of the person riding that bike. Ellen was training for a bike race. One afternoon, she grabbed her helmet and took her bike out of the street. She got on the bike and started to pedal, pushing hard to start moving forward. Which of the following is better evidence that Ellen's kinetic energy changed? When Ellen started pedaling her bike, she began moving along the street, or when Ellen got on her bike, her feet were no longer touching the ground. Kinetic energy is all about movement, so we would say that she's moving while she's pedaling. When the amount of any type of energy changes, an energy transformation is happening. When one type of energy decreases, the other energy increases. This is because energy transformations, energy is converted between types to that law of conservation of energy. Read the passage and again think about the energy transformation. Keep in mind that the muscle cells use chemical potential energy when they expand or contract to move parts of a person's body. Ellen was training for a bike race. One afternoon, she grabbed her helmet, took her bike out of the street. She got on the bike and started to pedal, pushing hard to start moving forward. Complete the sentence. When Ellen started riding, blank was converted into blank. Chemical potential energy was converted into kinetic energy. So she had eaten something, and the muscles that are on her body are allowing her to move in this way that turns into kinetic energy. Where do humans get this chemical potential energy from? Well, chemical potential energy that humans use comes from the molecules in our food. Human cells are able to take these molecules and then use chemical potential energy. Cells use this energy to help the entire human body function and move. During an energy transformation, the total amount of energy stays the same. So when a type of energy decreases, the another type increases. Read the passage about the next part of the ride. Think about how kinetic energy, chemical potential energy, and thermal energy changed. So again, we read the scenario. Ellen biked in a straight line along the street. Then, to avoid the sun, she moved over to ride under the shade of some trees. But as she pedaled faster and sped up, Ellen started to feel hot even in the shade. Decide how each type of energy changed. Ellen's thermal energy increased because her muscles are moving and that chemical energy being burned is giving off or releasing energy in the form of thermal energy. Ellen's kinetic energy stayed the same. She's still moving, and the chemical potential energy stored in Ellen's muscle cells is decreasing. So because she's still moving, there's no change in kinetic energy, but her chemical potential energy is decreasing because her thermal energy is increasing. There's a conversion that's taking place. It says that her kinetic energy is increasing, but that would be because she's moving. Ellen's speed increased as she pedaled. Mr. Shane missed that. So if she's increasing her speed, that would mean her kinetic energy is increasing. Got it. Read the same passage and think about the evidence of kinetic energy, chemical potential energy, and thermal energy, how they're changing. Ellen biked in a straight line along the street. Then to avoid the sun, she moved over to ride under the shade of trees. But as she pedaled faster and sped up, Ellen started to feel hot again. There it is, pedaled faster and sped up. Consider the following claim. While Ellen was pedaling, chemical potential energy was converted to both kinetic energy and thermal energy. Which piece of evidence best supports this claim? Well, the sun was bright during Ellen's bike ride, but she rode in the shade. Not really. Ellen's first rode in a straight line, then she turned. That doesn't tell us about the transfer of energy. Ellen used her muscles to move faster, and the effort made her hot. We would say that that's probably the reason why. So increase in that kinetic energy, increase in the burning of the chemical potential energy, therefore the output was the thermal energy. During an energy transformation, some types of energy may not change. Read the passage about the next part of the ride. Think about how kinetic energy, chemical potential energy, and gravitational potential energy change. Keep in mind that increasing the distance between an object and Earth increases the gravitational energy stored between them. Eventually, Ellen reached a hill. She pedaled as hard as she could to maintain a steady speed on her way up the hill. Click the blue words to correct the statement. Assume Ellen's mass did not change. As Ellen rode up a hill, her kinetic energy decreased. At the same time, the chemical potential energy stored in her muscles cells stayed the same, and the gravitational energy stored between her and the Earth increased. Well, she pedaled as hard as she could to maintain a speed on her way up the hill. So she is maintaining speed, so we're going to say her kinetic energy stayed the same. At the same time, the chemical potential energy stored in her muscle cells has got to decrease because she's pedaling ridiculously hard. The gravitational potential energy stored between her and the Earth increased. Let's see if we got that right. Nice work. Read the same passage, think about the energy transformation that's taking place. Eventually, Ellen reached a hill. She pedaled as hard as she could to maintain a steady speed on her way up the hill. Complete the statement. As Ellen rode up the hill, chemical potential energy was converted into gravitational potential energy. So she's going up the hill. The energy of position is now increasing as what's being used up, the chemical potential energy of her muscles, being consumed. By the time Ellen reached the top of the hill, she was exhausted and breathing hard, so she stopped pedaling and coasted toward a water fountain. As she coasted, she heard gravel crunch beneath her tires, and the bike slowed to a stop. Consider the following claim. While Ellen's bike was on the gravel, kinetic energy was converted to sound energy. Which piece of evidence best supports the claim? Ellen noticed herself breathing hard at the top of the hill. She heard the gravel crunch as her bike slowed, or Ellen was farther from the center of Earth when she reached the gravel top of the hill. You hear that sound energy, which means that kinetic energy, the motion of that, is being absorbed by the moving of those gravel molecules or gravel pieces. Was kinetic energy converted only into sound energy? Probably not, because as those pieces of gravel are pushed together, there's going to be some type of friction that creates thermal energy as well. Click the blue text to correct the passage about energy transformations during this bike ride. At the beginning of her ride, Ellen's muscle cells converted chemical potential energy into kinetic energy, so the bike started moving down the street. As Ellen started biking faster and getting hot, thermal energy was converted into chemical potential energy. We would say that kinetic energy was converted into thermal energy and chemical potential energy. As Ellen started biking faster and getting hot, chemical potential energy was converted into kinetic and thermal energy. So she increased that effort, which increased her speed and getting hot. Next, as Ellen pedaled up a hill at a steady speed, chemical potential energy was converted into gravitational potential energy. Looks good. And lastly here, it says biking up the hill made Ellen tired, so she stopped pedaling at the top. When the bike slowed down as she rode noisily over the gravel, we'd say that kinetic energy was converted into sound energy. Based on what you learned about the bike ride, which of the following statements about energy transformations are true? Select all apply. In all energy transformations, kinetic energy changes. An energy transformation involves two or more types of energy. Chemical potential energy in muscle cells can be converted into kinetic energy. I would say these two. Nice work. If you'd like to keep going on the bonus stage, feel free. Hopefully Mr. Shane's video helps you to complete both of these activities, H.3 and H.4. Make sure that you're working to get to that level of mastery for both of those. God's blessings.